Hi, everybody. We are going to review all of the different topics that we studied so far this year. These questions are intended to summarize the topics. Please select the best answer for each question. Remember that the basic equation for speed is speed equals distance divided by time. We're also going to apply Newton's laws of motion. So remember those. An object at rest stays at rest unless acted upon by net force. An object in motion stays in motion unless acted upon by a net force. And if it is acted upon by a net force, the mass will accelerate. F equals ma. Acceleration is the change in velocity over time. If we have zero acceleration, that means there is no change in velocity. The first question is a basic application of speed equals distance over time. So if Zachary can run the same distance as Aaron in less time, then he must be faster, right? Number 2, a bus trip of 15 miles takes 2 hours. What's the average speed? Well, speed is distance divided by time. Number 3, rank the acceleration from greatest to least. So what you need to decide is the greatest change in velocity over the least amount of time. Which one of these is changing rapidly? And then decide which one of these doesn't change at all. That's going to be your least. So rank them from which one changes rapidly and which one doesn't change at all. And then everything in between, rank them. The other two are going to be ranked somewhere in between. Number 4, look at these graphs here. What do these mean? Well, if my position is getting greater and greater, which means I'm getting further and further from where I started. I'm moving away from where I started, and I'm doing it over time, and I'm nice and steady. Well, that's constant speed, right? Constant velocity. Well, if it looks like graph B, where I'm getting further and further away from my origin, but as time goes on, the rate at which I'm getting away is increasing, so I must be speeding up. This one, I'm turned around and I'm going back towards where I started, the origin. Over time, I'm getting closer and closer and closer to the origin, and I'm doing it in a nice, steady speed. So that means I must be backing up at a steady speed. This one, I am getting further and further away from the origin, so I'm moving forward, but the rate at which I'm doing it becomes less and less. So I must be slowing down. Answer 4, 5, and 6. Question 7. If I have a shopping cart and I push it with a certain amount of force, it will accelerate at 2 meters per second squared. Then I take out some potatoes where the mass of the shopping cart goes down by half. Now I push the cart with the same force. How much will it accelerate? Well, acceleration with the same force on less mass, okay, A equals F over M. Let's pause. Acceleration goes as the same force over mass. But if I decrease the mass and I keep the force the same, then acceleration must increase, right? Because I'm making mass smaller, so A must get bigger. By how much, though? If I reduce mass by 1/2, how much bigger will A be? No matter what the ball is doing, going up or coming down, there is still only one force acting, and that is gravity. So answer the questions 9, 10, 11, and 12. Number 13. A ball rolls horizontally off a table and falls to the floor, as shown. When the ball was rolling, we had constant horizontal velocity. Even when it leaves the table, it will have constant horizontal velocity because gravity will not change the horizontal velocity. However, gravity does change the vertical velocity. So pick the diagram that shows constant horizontal velocity, but increasing vertical velocity. Number 14. 3 towers have the same height. Well, we know that all objects, if they are dropped from the same height, will land at the same time. The only difference here is that this ball was thrown sideways and this ball was thrown sideways. But we know that the vertical velocity only depends on gravity, and as long as these balls are thrown or dropped from the same height, they will land on the ground together. Number 15, 16 are projectile motion. We know that in order for the football to go this distance, it must have horizontal velocity. But it also needs time in the air, and that requires height. So the football needs to be kicked somewhat to the right, but also up. So it needs some horizontal velocity, and it needs some time to get up to high enough so that it stays in the air long enough. So we need time in the air. Maximum time would be kicking straight up. Maybe we get higher. But straight up means there's no horizontal velocity in order to make distance. What if it was kicked really low? Lots of horizontal velocity, but not enough height. Well, then it would fall back to the ground sooner, and we wouldn't have the chance to make this distance. So there's a trade-off. We need a little bit of horizontal velocity and a little bit of time in flight. So about half and half. This girl throws a ball this way, but she's on roller skates, so she tends to accelerate backwards a little bit. Why is that? Well, both have inertia. The ball has inertia, the girl has inertia. The ball is going to resist the change. So when she pushes the ball this way, the ball fights back and pushes her this way. These forces are the same. She will accelerate a little bit. The ball will accelerate more, not because the forces are different, but because the masses are different. The girl has more mass, so she has a less of an acceleration due to the same force. So she has same force, less acceleration. Over here, same force, more acceleration. Number 18, when an object is not accelerating, which of the following must be true? Well, no acceleration means no net force. And no net force means all forces balance. Number 19, when we have two forces acting at the same time, what do we do? Well, forces are vectors. So if we add two vectors that are at 90 degrees to each other, we do the rectangle method. So construct a rectangle, draw a dotted line this way, and then draw another dotted line this way. And where the two intersect, it makes a rectangle. Draw the diagonal of the rectangle, and that will be the value of the resultant force. It's going to be diagonal, so a little bit longer than the 10. Number 20, normal force and weight. Are they always equal? Well, sometimes they're equal. Okay, but what if our surface is tilted a little bit? If the surface is tilted, then the normal force will also be tilted, and it will not balance with weight, which is always straight down. Straight down, right? Weight has to be straight down, but the normal force does not always have to be straight up. That concludes the review of the topics for this assignment. Thanks for watching.